Now we are starting trigonometry. So how do we solve this? How do we solve this if we don't know all of the sides and can't use the Pythagorean theorem? So notice in our triangle we don't have all the side measures, so we can't use the Pythagorean theorem. So we're going to use trigonometry, which is a ratio that uses the sides of a right triangle and the angle measures. So now we're going to introduce using angle measures as well as side measures. SOHCAHTOA. SOHCAHTOA is a way to remember how to set up the ratios of the sides to solve for sides or angles. So now we're going to look a little bit more in depth at sine, cosine, and tangent. So sine. Its acronym is SOH, which stands for the sine equals the opposite over the hypotenuse. And the opposite is the side that is opposite the angle. So down in our diagram we have 37 degrees, and our opposite side would be 13. So we use this when we're given a problem where you have an angle, the side opposite the angle, and the hypotenuse. So in our little triangle below we have 37 degrees, we have the side opposite, which is 13, and then we have our hypotenuse, which is x, because it's opposite the right angle and it's the longest side of the triangle. So for this problem, we would use sine to find x. Cosine, C-A-H. It stands for the cosine equals adjacent over hypotenuse. Adjacent means the side that is right next to the angle, that is not the hypotenuse. So down in our triangle, we have our degree measure 37 degrees, and our adjacent side would be x because it's right next to our angle, and it is not the hypotenuse. So we're going to use the cosine when given an angle, the side next to the angle, and the hypotenuse. So again, we have 37 degrees, our adjacent side would be x, and our hypotenuse would be 13 because it's opposite the right angle. So for this problem, we would use cosine to find x. Finally, tangent, T-O-A. This stands for the tangent equals the opposite over the adjacent. So we're going to use this when given an angle, the side opposite the angle, and the side right next to the angle. So down in our picture we have 37 degrees. We have our side opposite, which would be x, and we have our side that's adjacent, which would be 13, because it's right next to the angle and it is not the hypotenuse. So we're going to use the tangent to find x. So example 1, we're going to be solving for a side. So we have our diagram down here. We have a 24-degree angle. We have one side being x and one side being 19. So what trig function would we use? We're going to use the tangent because we have the adjacent and opposite sides. So we have our adjacent side, which would be 19 because it's right next to the angle and it's not the hypotenuse, and we have our opposite side, which is x, because it's opposite the angle. So that's how we know that we're going to be using the tangent. So we're going to plug it into this equation. The tangent of the angle equals the opposite over the adjacent. That's our TOA. Opposite over adjacent. So we have the tangent of 24, which is our angle measure given, equals x, which is our opposite side, over 19, which is our adjacent side. So now we're going to solve for x by multiplying both sides by 19 to get x by itself. So we'll have 19 times the tangent of 24 equals x. Now you're going to plug that into your calculator, and you'll get x equals 8.46. Example 2, solving for a side. So we have our picture, and what trig function should we use? So we have 17 degrees and we have two sides, one is 6.6 and one is x. So when we look at it, we're going to be using sine because we are given the opposite and hypotenuse sides. So if we have our 17-degree angle, we have our opposite side, which is 6.6 because it's opposite the angle, and then we have our hypotenuse, which is x because it's opposite the right angle, and it's the longest side of the triangle. So we're going to look, and we have opposite and hypotenuse, so we're going to be using sine, S-O-H. So we're going to plug in to sine times the sine of the angle equals the opposite over the hypotenuse. So we're going to plug in what we know. So we have the sine of 17 degrees, which is our angle, equals the opposite side, which is 6.6, over the hypotenuse, which is x. Now we're going to solve for x. First, we're going to multiply each side by x. So we get rid of that x on the denominator on the right. So we'll have x times the sine of 17 degrees equals 6.6. And then to get x by itself on the left, we're going to divide by the sine of 17 degrees on both sides. So we'll have x equals 6.6 divided by the sine of 17 degrees. This is when you plug it into your calculator. So your x is going to be 22.6. Example 3. Solving for a side. What trig function should we use? So we have our 31-degree angle, we have an x, and we have 34. We should use cosine because we are given the adjacent and hypotenuse sides. So we have 31 degrees, and our adjacent side is x because it's right next to the angle, and then our hypotenuse is 34 because it's the longest side of the triangle. So now we're going to just plug it in to the cosine of the angle equals the adjacent over the hypotenuse. So we'll get the cosine of 31 degrees equals the adjacent side, which is x, over the hypotenuse, which is 34. Now we're going to solve for x by multiplying each side by 34. So we'll get 34 times the cosine of 31 degrees equals x. And we're going to get x equals 29.1 once you plug it into your calculator. Now remember, you're going to want to have your calculator in degrees, not radians. And you're going to use your sine, cosine, and tangent buttons that are on the calculator. So you're going to plug it in right as you see it. 34, and then you'll press your cosine button, and then you'll put 31, enter.